Ever pondered why arrays hold such a significant place in C++ programming? Well, if you haven't, then you're in for a treat. Let's delve into the world of arrays and their importance in C++. Arrays are fundamental, not just in C++, but in all programming languages. Think of them as the building blocks of data organization and manipulation. They serve as containers that hold multiple values under a single name. And in a world where data is king, being able to manage and manipulate large volumes of data is crucial. That's where arrays come in. Imagine you're a librarian with thousands of books to manage. Without a proper system, locating a particular book would be like finding a needle in a haystack. But if you organize the books on shelves and label them, it becomes easier to find a specific book. That's precisely what arrays do in programming. Arrays provide a systematic way to store and manage data, making it easier for programmers to keep track of information. They allow programmers to store a set of values, whether integers, floats, or characters, and access them using an index. This way, you don't have to create a separate variable for each value, making your code cleaner and more efficient. But that's not all. Arrays are also essential in executing complex algorithms such as sorting and searching. They enable programmers to perform operations on multiple data elements simultaneously, speeding up computation and saving precious time. Moreover, arrays are intrinsic to data structures like stacks and queues, which are pivotal in solving complex programming problems. They also play a vital role in multi-threaded programming, where handling large data sets effectively and efficiently is paramount. In essence, arrays are the backbone of C++ programming. They are the unsung heroes working behind the scenes to make your code efficient, clean, and manageable. So, understanding arrays is key to mastering data organization and manipulation in C++. Now, dive into the core concept of arrays. Consider arrays as the ultimate storage boxes in the world of programming. They are like a row of lockers where each locker holds a value, and all these lockers share the same identity. Each value is stored in a specific locker or an element, and these elements are neatly arranged in a contiguous memory location. This allows for easy access and management of multiple values that are of the same type. In the realm of C++, arrays come in handy when you want to store and manipulate a collection of similar data types. This could be a series of integers, characters, or even floating point numbers. The beauty of arrays is in their simplicity and efficiency. They provide a systematic way to handle data, making your code cleaner and easier to understand. But how do we declare an array in C++? Well, the syntax is quite straightforward. First, you specify the type of data you want to store. This could be int for integer, char for character, and so on. Then, you provide a name for your array, something that's relevant to the data you're storing. Finally, in square brackets, you define the size of your array, which is essentially the number of elements it can hold. So, if you're declaring an array of 5 integers, you would write int myArray. A point to note here is that arrays in C++ are zero-indexed, which means the first element is at index 0, the second element at index 1, and so forth. This might seem a tad counterintuitive at first, but once you get the hang of it, it's a piece of cake. What's more, arrays are not just about storing data. They also provide a foundation for more complex data structures like stacks, queues, heaps, and hash tables. But that's a topic for another day. So, an array is essentially a powerful tool for storing multiple values in a single variable. And with that, we've unraveled the core concept of arrays in C++. Having understood what arrays are, the next step is to learn how to initialize and access array elements. Let's start with array initialization. When we declare an array, we can also initialize it. For instance, suppose we want to create an array of integers with 5 elements. We can declare and initialize it in one go like this. Int myArray = 1, 2, 3, 4, 5. In this case, the compiler automatically determines the size of the array based on the number of elements we've included. Next, let's talk about how to access each element of the array. Each slot in an array corresponds to an index number. Think of it as the address of a house in a street. The first house, or in our case, the first element, starts with an index of 0. So if we want to access the first element of our array, we would write my array. This would give us the number 1, which is the first element in our array. Now, if we want to access the second element, we would use an index of 1 like so, my array. This would give us the number 2. This continues all the way up to the last element of the array. In our case, the last index would be 4, not 5, because remember, indexing starts from 0. To access all elements of an array, we can use a loop. For example, a for loop can iterate through each index, allowing us to access each element in turn. This is particularly useful when we want to perform operations on each element of an array. So to recap, initializing an array involves declaring it with a set of values. Accessing elements in an array is done using index numbers, which start from 0. By understanding these fundamental concepts, you're well on your way to mastering arrays in C++. Remember, in C++, array indexing starts from 0. Now that we know how to access array elements, let's explore how to manipulate them. When we talk about array manipulation in C++, we mainly focus on 3 operations: insertion, deletion, and updation. These operations allow us to modify the array data as per our needs. Let's take a quick dive into each one of them. First up, insertion. To insert an element in an array, we need to shift the elements to the right of the insertion point. For instance, if we want to insert an element at the 3rd position, we move the 3rd and following elements 1 position to the right. Then, we place our new element in the 3rd position. Remember, the array size increases by 1 after insertion. Next, deletion. Deletion is somewhat the reverse process of insertion. To delete an element, we remove it and shift all elements to its right, 1 position to the left. For example, if we delete the 3rd element, the 4th becomes the 3rd, the 5th becomes the 4th, and so on. After deletion, the array size decreases by 1. Lastly, updation. This is the simplest operation among the 3. To update an element, we replace the existing value at a particular index with a new one. For example, to update the 3rd element, we simply place the new value at the 3rd position. The array size remains the same in this case. While performing these operations, 2 things are of utmost importance: knowing the array size and managing the array index. The array size helps us avoid data overflow or underflow. The array index, on the other hand, helps us access the correct element. Remember, in C++, array indexing starts from 0. Mastering these array manipulations is like learning the ABCs of programming. They form the basis of many complex algorithms and data structures. Array manipulation is a crucial skill in C++, enabling you to modify data as per your requirements. Let's quickly recap what we've learned about arrays in C++. An array, in essence, is a sequence of elements of the same type, stored in contiguous memory locations. This structure allows us to store multiple values under a single name, which can be accessed using indices. We've explored how to initialize an array, which is as simple as declaring the type, followed by the array name and size, and optionally, the elements. Remember, array indices start at 0, much like the first chapter of your coding journey. We also delved into the concept of accessing array elements, which we can achieve by referencing the array name followed by the index in square brackets. It's like picking a book from a numbered shelf, knowing exactly where it is. In terms of manipulation, we discussed how to insert, delete, and update elements in an array. Though it's important to note, these operations aren't as straightforward as with other data structures. They require shifting of elements, which can be computationally expensive. But why are arrays so significant? Well, arrays form the backbone of many problem-solving techniques in programming. They are used in various sorting algorithms, like bubble sort, selection sort, and quicksort, where elements of an array are rearranged in a specific order. They're also utilized in searching algorithms like binary search, where we continually divide the array to find a particular element. Moreover, arrays are fundamental in data structures like heaps and hash tables, and they're used in storing data for graphs and matrices. They're the unsung heroes working behind the scenes, making your programs more efficient and your code cleaner. So, as we wrap up our exploration of arrays in C++, remember that understanding and mastering this simple yet powerful data structure is like acquiring a secret weapon. A weapon that can help you tackle complex programming problems, devise efficient algorithms, and ultimately become a proficient programmer. Mastering arrays in C++ will equip you with a powerful tool to solve complex programming problems efficiently.